Guys, this is Dr. Manjunath Chennapugod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about Otto Cycle. What is Otto Cycle and what are the important processes are there in Otto Cycle? What are the importance of Otto Cycle? Why it is invented? Who is invented? And we done a derivation for calculating the efficiency of an auto engine. And also we done some numericals on the Otto Cycle in the previous videos. So dear students, today I will move towards next problem on Otto Cycle. Okay, so numerical on Otto Cycle. Okay, so first now problem number 3 or numerical 3. I will read the problem first. A 4-cylinder petrol engine has a swept volume of 2 into 10 to the power of 3 meter cube and clearance volume in each cylinder is 6 into 10 to the power of minus 6 meter cube full stop. If the pressure and temperature at the beginning of the compression are 1.02 bar and 24 degree Celsius and the maximum cycle temperature is 1400 degree Celsius. Calculate first one air standard efficiency, second one the mean effective pressure. Okay, fine. Next he has given assume for air the specific heat at constant pressure, that is 1.005 kilojoules per kg Kelvin. Second one, specific heat at a constant volume of air, that is 0.716 kilojoules per kg Kelvin. This is the problem, dear students. Now, so now first what actually he is telling now? He is telling there is a 4-cylinder petrol engine. That you can see here now, dear students. There is a 4-cylinder petrol engine. We can take an example of car. That car having 4 cylinders here now. Cylinder number 1, cylinder number 2, cylinder number 3, cylinder number 4. There is a 4-cylinder petrol engine that you have to mark it. That is very important here now. This is what it is operated on a petrol engine or a gasoline engine. That means what? Petrol engine or a gasoline engine are designed with the help of what? Otto Cycle. So it is a petrol engine. Fine. Now, then what all things he has given, you have to understand here now. So what all now? It is a four-cylinder petrol engine that I have taken. The next he has given some basic data which are related to engine now. What are the basic data he has given? That you can see here now. So he has given some data which are related to engine now. Either it may be 1 cylinder or 4-cylinder. He has given some data that we will listing out now here now. So now what are the things he has given, dear students? We can see here now. The next thing is he has given some parameters. He has already given in the problem now. What is swept volume? He has given a 4-cylinder petrol engine as a swept volume. That means what? He has given swept volume for whole cylinder now. Whole engine he has given. That means what? Swept volume for what? All engines. Swept volume of cylinder 1, swept volume of cylinder 2, swept volume of cylinder 3 plus swept volume of cylinder 4. Then you are going to, when you are add all the swept volume of all 4 cylinders, then you are going to get the total swept volume. But he has given total swept volume he has given. That's fine. Next he has given, next you can see now, and the clearance volume in each cylinder. He is telling now each cylinder. That means what? He has given total swept volume. I will write it here VST for my understand. Total swept volume he has given. That means what? He has considered 4-cylinder and he has given swept volume for whole 4 cylinders. Fine. Then he has given clearance volume, but that clearance volume is not given total clearance volume for all cylinder, but he has given clearance volume for what? Only 1 cylinder. That clearance volume I will denote it here as a VC. Okay, fine. Next, then he has given the pressure and temperature at the beginning of the compression. So before starting the compression, the pressure and temperature of the air fuel mixture is 1.02 bar and 24 degrees Celsius. Hence what I can say, initial pressure he has given, initial temperature he has given. Initial pressure I will mark it here as a P1. That P1 is equal to 1.02 bar he has given. Then he has given initial temperature. That initial temperature I will mark here as a T1. The T1 he has given in 24 degrees Celsius he has given. That you can convert into Kelvin by adding 273. Okay, fine. Next, read the problem now. Now he has given the maximum cycle temperature he has given as 1400 degrees Celsius. That means what? Maximum cycle temperature. I will tell you what is the maximum temperature, cycle temperature. That is nothing but what? T3. The T3 is equal to how much he has given? 1400 degrees Celsius he has given. These are the data which are given in the problem now. These all data is related to what? Otto cycle or Otto engine. With the help of this data, what he is asking to calculate? He is asking to calculate first one, swept volume per cylinder. That means what he has given, 4 cylinder total swept volume. Okay, but he is asking to calculate the swept volume per cylinder. Then what you can do now? Then if you want to calculate this swept volume per single cylinder, then what you can do now? Total swept volume of total divided by how many cylinders are there? 4 cylinders. Then what you will get now? Now you will get the swept volume for a single cylinder. That you can do it, fine. Next, you need to calculate the compression ratio now. Compression ratio, you need to calculate what is the compression ratio, that we know R equal to V1 by V2. Okay, next he's asking to calculate the air standard efficiency. We derived the equation for air standard efficiency for what? Otto cycle. Is asking to calculate air standard efficiency is equal to how much. These are the calculations we need to do. Based upon these calculations, what we can do, we can tell the percentage of the engine, efficiency of the engine we can tell, and performance inside of the engine we can tell based upon these calculations. Okay, now what we can do now, this is the data I have listed it here now. But dear students, while solving problem is simple, but try to understand the fundamentals, basics, analyze the problem thoroughly, and list out the given data properly, and list out the important formula which are required to this particular problem. That is very important. Analyzing the problem is one of the important step in solving the numericals. Okay, now, so as I told, these students, you will confuse, right? You should know what is swept volume, what is clearance volume, because all will come here now. What is swept volume? Swept volume is the volume which is occupied by the air fuel mixture from point BDC to TDC. That is, we can call it as a swept volume. The distance moved by piston from point BDC to DC, that distance we can call it as a stroke length. That is represented as a L actually. With the help of this L and bore diameter, we can calculate the swept volume. Once you know the swept volume, then what you can do? Clearance volume. What is clearance volume? The clearance volume is a volume occupied by the air fuel mixture from cylinder head to the TDC. That is known to be clearance volume. If I want to calculate the total volume occupied by the air fuel mixture is VC plus what we can say now? VS. This is what? VS. This is what? Total volume. Okay, total volume. So when TDC and BDC. So these are all the things he has given now. Now you have to understand the working principle of Otto cycle also. So what actually he is telling now? Initially piston is at TDC. The starting point is point 1. Assume that point 1 is what? Your BDC. Point 2 is your TDC. Just a minute. I will mark it with a different color. You can understand easily. Okay. Find 1 and find 2. Point 1 to 2, what you can do? If the piston start to move from point, this is a piston, right? This is a piston, you can see here now. This is a piston. If you start to move from BDC to TDC, then what happens? The whatever the air fuel mixture is there inside the cylinder, right? That will be get compressed. How it is going to compress? It is going to compress without any heat transfer from system to the surrounding or surrounding to the system. That is nothing but what? Adiabatic compression. Once the piston moved from BDC to TDC, it is going to happen a process. That process we can call it as a adiabatic compression. Adiabatic compression. Now the piston is at particular point TDC. The air fuel mixture gets compressed. Then compressed. That volume we can call it clearance volume. When it is already get compressed, right? The pressure is increased from P1 to P2. So here now, initially it is having a pressure P1. Okay, and temperature T1. Initially it is low. When it is the air fuel mixture get compressed, right? Pressure also increases, temperature also increases. The increase in pressure and temperature we can mark here P2 and T2. Once it is gets compressed, once the piston is at particular point TDC and air fuel mixture is gets compressed, at that moment what we are doing, with the help of a spark plug, what we are doing now, with the help of spark plug, what we are doing now, we are going to supply the heat now. Heat supply is represented as, just a minute, heat supply can be represented as a QS, or some authors they will take a QS, some authors they will take a QA, some authors they will take, some authors, just a minute, some authors they will take QH also. It's up to you. Okay, when you are going to add heat to the compressed air fuel mixture, right, then what will happen? Sudden combustion will take place. If the sudden combustion takes place, what will happen? Explosive force is going to create over the surface of the piston, hence is going to create the explosive force. Okay, once sudden heat is added to the air fuel mixture, right, sudden what will happens now? Temperature as well as pressure still increases from P2 to P3. Still again the temperature and pressure is going to increase. That means what? P2 to P3, temperature T2 to T3. Once it happens, right, then what happens? The sudden explosive force act on the surface of the piston. What happens? The pistons will start to move from TDC to BDC. Here you can mark as a point. Now 3 and 4 now. Again it will start from here, right? 3 and 4 you can make. The piston, once the piston exerted, once the hot gases, because of combustion, what happens? That hot gas is going to exert the explosive force over the surface of the piston. Hence the piston will start to move from TDC to BDC. That point you can call it as a 3 and 4. If the piston start to move from 3 to 4, you can say, just a minute. If it start to move from 3 to 4, that means what? Expansion. How the expansion is taking place? But the whatever the heat is there inside the cylinder, right, it is not at all taking out, or it is not at all moving out. Hence Q equal to 0. If the heat transfer is not at all there in that process we can call it as expansion. Then if there is no heat transfer, that we can call it as a adiabatic expansion. 3 to 4. Okay, 3 to 4. Once it reaches, now piston will come, it will reach the 3 to 4. Once it reaches 4.4, right, then what we are going to do, we are going to open the exhaust valve. Once the exhaust valve is removed, then what happens? Hot gas is coming out. That means what? It's, if the hot gas is coming out, means what? Heat is getting rejected. Again, what process we can call? That process we can call 4 to 1. The heat is getting rejected. And again, what now? What is the important here now? Both you can see now. You are adding heat at constant volume, V is constant, and also you are removing heat at a constant volume. So, sorry, you are removing heat is getting rejected at constant volume. So V equal to constant. Heat addition, we can mark it here now. Heat addition and heat rejection, they are taking place at a constant volume. That process we can call it as a Otto cycle, dear students. Now this is what? Variation of pressure pressure versus volume. Okay, so that we have done. Now if I want to know the variation of temperature, because when the piston is moving from BDC to TDC or TDC to BDC, when the piston is going to move up and down, right, it is going to have some different process. That different processes having different temperature at different points. You can see now at point 1 it is having temperature T1, at point 2 it is having temperature T2. Like that, variation of temperature can be also can be calculated with the help of TS diagram, that you can see here now, dear students. TS diagram. Process point 1 to 2. 1 to 2 is what? Compression. 1 to 2 is compression. That means what? Piston is moving from BDC to TDC. That means what? 1 to 2. This is what? Process 1. Compression process we can call. But there is no any heat transfer, that we can call it as adiabatic compression. Once it is air fuel mixture gets compressed, then what we are doing now? You are going to add a heat actually. That heat addition is represented as a QS. Once the heat addition is taken place from 2 to 3, then what happens now? Immediately explosive force is going to act on the surface of the piston. Hence what happens now? Piston will start to move from 3 to 4. That is nothing but what? Expansion. That we can call it as 3 to 4 is expansion, you know. What type of expansion? Again, adiabatic expansion. There is no heat transfer at all. Adiabatic expansion. Once the work is done, what we are going to do? We are going to open the exhaust valve. Hot gas will come out. If the hot gas is come out, that means what? Heat is getting rejected from 4 to 1. That also you can show it in the TS diagram. This is how the engine works, dear students. Okay, Otto cycle works actually. So now, what are the findings now? Now this is, you understood, right? You understood now how it works. What is the principle? What is BDC? What is TDC? What is compression? What is heat addition? Expansion, heat rejection? Everything you understood now. Now the main thing is what? Now you have to analyze the problem. So what all things you have to analyze here, that is important here now, dear students. First, what you have to do in this problem, initial conditions, what you have to do, you have to list out what is starting pressure, temperature, what he has given, that you have to list out. Then whatever the swept volume he has given, whether he has given individual swept volume or total swept volume, we have to list out. But before list outing the swept volume, you should know what is swept volume. What is swept volume? Volume, the swept volume is a volume which is nothing but the volume displaced by piston movement. That means what? BDC to TDC. That fundamentals you should understand, dear students. Solving problem is simple, but try to understand the problem thoroughly. Okay. Next, what you have to do? You have to understand what is compression ratio. So what is compression ratio? Ratio of total clearance volume. That means R equal to, that is nothing but what? R equal to total volume to the clearance. Volume is nothing but what? Compression ratio. That definitions you should know. The fundamentals you should know. Then air standard efficiency. What is air standard efficiency? That also you should know. That is theoretical efficiency of Otto cycle. That we already know. We have derived the equation that we need to calculate. Okay. Next, after that air standard efficiency, what you have to do? You have to calculate the mean effective pressure. What is that mean effective pressure? That pressure which is going to act over the surface of the piston is nothing but what? Mean effective pressure. These are the some important terms you should know before calculating the Otto cycle efficiency and mean effective pressure for a given problem. We understood problem well now. So step by step you can, now you have to analyze the problem step by step, and you have to list out what all he has given, then what all you have to do. That is the first thing here now. The first step now, you understood the problem well now. What is the first step now? First step, convert units. Whatever the unit, sometimes pressure he will give in terms of bar, pressure he will give in terms of Pascal, pressure he will give in terms of Newton per meter square, like that. Temperature sometimes he will give in terms of degree Celsius, sometimes he will give it in terms of what? Kelvin. But you should be convert the unit and make a consistency, then only we can solve the numericals and we can get the correct answer. That is the first step. Now second step, note the given values. What all the things he has given? He has given some basic data, T1 and P1 he has given. Okay, that you have to list out first. Okay, that you have to list out all parameters. Swept volume he has given, clearance volume he has given, initial pressure, that is P1 he has given, T1 he has given. Next, what he has given? Next, that maximum cycle temperature he has given, that you have to list out. That is what second step. Then third step, calculate the compression ratio. Now he has, sometimes he will give the bore diameter, sometimes he will give the total length, the stroke length he will give. With help of that data, what you have to do, you must calculate the compression ratio with help of the given data. Okay, but in this problem he has given total swept volume here, swept volume he has given. Then you can calculate the swept volume for an individual cylinder. That is nothing but auto swept volume, total swept volume divided by 4, you will get the swept volume for an individual cylinder. With help of that swept volume and clearance volume, you can calculate the compression ratio. Then dear students, you have to determine the pressure at a you have to determine the temperature at T3. But you should know, dear students, what all things he has given, that is very important here now. What all things he has given? Sometimes he will give the maximum temperature, maximum cycle temperature he will give, sometimes he will give maximum cycle pressure also he will give. Now what all things he has given, what you need to calculate, that you have to identify correctly. Okay, so now he has given maximum cycle temperature, but he has not given pressure, that we need to identify. Dear students, you can see it in this in this okay PV diagram. So here now, this is what, where you can get the maximum pressure, here at point 3, that is maximum pressure you can get. That means what, you need to calculate the P3. Where you have to calculate the P, how to where you have to calculate the maximum cycle pressure? At point 3. What is the pressure at point 3? That is P3. What is the temperature at point 3? That is T3. So you need to calculate the pressure at temperature T3. That you need to calculate. That process, that step we can call it as a fourth step. Once you calculated the pressure and calculated the pressure at maximum point, then what you have to do, you have to calculate the heat input now. So now when it compressed, when you are going to supply certain amount of heat, right, you are telling certain amount of heat. Now how much amount of heat you have supplied, that you need to calculate. Now how to calculate that heat supplied? Just a minute, I will show you here now. Now you are supplying heat here, right? That heat supplied, we need to calculate. How to calculate? That we can calculate as Qs is equal to M into Cv into, what is the maximum temperature now? T3. So that is T3 minus, what is the minimum temperature? That is T2. So how much amount of heat you have supplied during process 2 to 3, that you can calculate. That is what? Fifth step. Then sixth step, once you supplied the heat, right, according to first law of thermodynamics, if you supply certain amount of heat to the body, then that body is going to do some amount of work. That work we need to calculate. That means what? Q is equal to work. First law of thermodynamics, amount of heat supplied is equal to amount of work done. That we know already. So if once you supply certain amount of heat, you need to calculate the work done. That is sixth step. Then seventh step is now once you know the value of Qs, that heat supplied, once you know the value of work done, then you can easily calculate the efficiency of the cycle or efficiency of the engine. What is that cycle efficiency? Generally we know it, efficiency is equal to, it is the ratio of work done to the heat supplied. So efficiency of a cycle or engine is nothing but what? It is a ratio of work done to the heat supplied. Once you know the value of W from this step 6, once you know the value of Qs from step 5, what we can do? We can calculate the efficiency. Then that efficiency you can put it in terms of percentage. The last step is achieve maximum temperature. Once you got the maximum temperature, right, maximum temperature and pressure and all values you need to list out. This is the step by step how to solve the numericals with the help of what? Otto cycle. Now we will solve now. So once again, quick recall, what is the swept volume he has given? He has given the swept volume for what? Total swept volume he has given, that you can mark it as a VSC. Now notation you however want you can take, these students. I will take here VS total. That means what? Total swept volume. That means what? He has given swept volume for 4, he combined all swept volume and he has given only one swept volume. That is equal to how much? 2 into 10 to the 4 of minus 3 meter cube he has given. Then how many cylinders are there in the engine? 4 cylinders are. Then what will happen now? If you want to calculate the swept volume for individual cylinder, then what will happen now? 2 into 10 to the 4 of minus 3, just a minute. 1 minute. I will write it another. Okay, so now we know swept volume. If I want individual swept volume, what I can do now? 2 into 10 to the 4 of minus 3 divided by number of cylinders. What are how many cylinders are there? Number of cylinders, you can mark it here now. 2 into 10 to the 4 of minus 3 divided by what? 4. Then you will get the swept volume for an individual cylinder. That we need to calculate here now. Then he has given some basic data. What are the things he has given? Initial pressure he has given. That initial pressure I will mark here as a P1. That P1 is equal to 1.02 bar is there. That bar we can express in terms of kilopascal also. Okay, then he has given initial temperature. Initial temperature we can mark as a T1. Then T1 is equal to how much he has given? 24 degrees Celsius he has given. That we can express in terms of Kelvin by adding 273. So if you add 273, then you are going to get 297 Kelvin. Okay, fine. Now with the help of this, and also he has given in the problem some maximum temperature he has given, that is 1400 degrees Celsius he has given. At 273 you are going to get 1673 as a 1673 Kelvin as a maximum cycle temperature. Then to solve the numerical, he has given some specific value. Specific heat he has given, specific heat capacity he has given. What is that? Specific heat at constant pressure is equal to 1.005. specific heat at constant volume he has given 0.716 he has given. With the help of this two data we can calculate the gamma value. Some authors they will take gamma, some authors they will take K. So that is nothing but what? Cp divided, it is a ratio of specific heat of constant specific heat of a gas at constant pressure to the specific heat of gas at constant volume. That we have to calculate. With the help of this data we can solve the numericals. So these all give data I have listed here now. Next. Now what are the things, dear students? Quick recall you can see here now. So the initial data, swept volume he has given, initial pressure he has given, that is P1, so P2 and T2, P1 and T1, okay, P3 T3, next P4, T4. Similarly, you can take a volume also, V1, but here constant volume V1 is equal to V4, V2 is equal to V3. This is what Otto cycle. Now we have listed the given data. Fine. Now we will solve the problem step by step. First step is what? I will go with what? There are two findings. One is air standard efficiency. Second one, mean effective pressure. So first what I will do? I will go with what? First one, that is air standard efficiency. To calculate that air standard efficiency, I should calculate some basic data. What are the basic data? You should know. You should know what is P1. P1 he has given in the bar itself, but in the problem itself he has given total swept volume, that is 2 into 10 to the power of minus cube minus 10 to the power of minus 3 meter cube. Then clearance volume per cylinder. Each cylinder means what? Per cylinder he has given 16 to 10 to the power of minus 6 meter cube. It is 10 to the power of minus 6, that you have to remember. P1, T1 he has given. Then T3 also he has given, that I converted into Kelvin. T1 I converted into Kelvin. T3 also I converted into Kelvin. CP and CB he has given, that I have listed here now. Once you listed all the data, then what we can do now? You can go with second step. What is second step? You can calculate the swept volume per cylinder, single cylinder. So that means, how to calculate now? Swept volume per single cylinder is swept volume for total swept volume divided by number of cylinders. Vs is equal to 2 into 10 to the power of minus 3, that is in meter cube, divided by 4. Then what you will get now? You do simplification, you are going to get Vs is equal to 5 into 10 to the power of minus 4 meter cube. This is what? Swept volume for single cylinder. Dear students, you have to remember what we will do. We will do calculations per cylinder, then we are going to multiply with the all cylinder to calculate the power, or work done. But initially what we will do? We will calculate the efficiency, work done, everything per cylinder. Okay, so now I calculated swept volume per cylinder. Fine. Next step, what? With help of this swept volume, he has given two data, right? So swept volume we have calculated here now, but swept volume directly is not at all given. He has given in terms of indirectly. That means what? Total he has given, but you calculated swept volume per single cylinder. Then you already clearance volume also he has given in the problem itself. Per cylinder, Vc and Vs you know. Once you know the value of Vc and Vs, we can easily calculate the compression ratio. What is the compression ratio? I told, that is nothing but V total divided by Vc. What is V total here now? V total, that is nothing but what? That also I told. V total is nothing but what? Vs plus Vc divided by Vc. So the same thing I am using now. Compression ratio is equal to V total, that is V total per cylinder I am considering, that you have to remember now. Total volume of single cylinder, that is nothing but what? Vs plus Vc divided by Vc. What is Vs? That we already calculated here, that you need to substitute. The next plus what is Vc? Vc is given in the problem itself, that too per cylinder. Substitute. Then what is divided by Vc. Again Vc you know. Do simplification, you are going to get the compression ratio as R equal to 9.33. Now you understand, you calculated the R value. Why it is required R value? Because I am calculating the air standard efficiency. To calculate the air standard efficiency, I require the value of R, because we done derivations for Otto cycle, right? That derivation, in that derivations we required R value, that is compression ratio I required. How it is, that we can see here now, dear students. To calculate air standard efficiency, we know the formula that we already derived. What is that? Air standard efficiency for Otto cycle is neta is equal to, just a minute. So neta is equal to 1 minus 1 divided by R to the power of K minus 1. Here R is what? Compression ratio. K is what? That is gamma value, specific heat ratio, that we know already. So then what I can do now? K is the specific heat ratio. We can find this K using Cp and Cv. How to calculate that K value? As I told, dear students, K is equal to that K, as I told, some authors they will take gamma, some authors they will take K value. It's up to you, but in the nomenclature you have to give very clearly where how to give, where gamma or K is equal to specific heat ratio, that is Cp by Cv, that you have to give clearly in the nomenclature. Fine. So now I have taken, now K is equal to, I will take K here, notation I will take K here, that is K is equal to Cp by Cv. What is Cp? That is also given in the problem itself now, that you can see here now, dear students. In the problem itself he has given Cp value and Cv value he has already given. With help of that, what I can do, I can calculate the value of what? K. So Cp is equal to 1.005 divided by 0.716 kilojoules per kg Kelvin. Kilojoules per kg Kelvin get cancelled. Then there is no unit for the specific heat ratio. Then after doing substitution, simplification, you are going to get the K value as 1.404. That we can take 1.4. That is what specific heat ratio, that is K. Once you know this case specific heat ratio, then what you can do, you can easily calculate the A standard efficiency now, because 1 minus R already we know, already we calculated, that is 9.33 something else. Then K you already calculate, substitute the all K and substitute R and K value in this equation. Then what you can do now, so efficiency 1 divided by 1 minus, then R 9.33, K is 1.404 minus 1. Do simplification, you are going to get efficiency is equal to 0.60. Multiply with 100, then what you will get now? You will get efficiency as 60%. So therefore standard efficiency of approximately it is 60.6%. Okay, first parameter is done. Then what to do now? Next, second parameter. What is the second parameter, dear students? That you can see here now. That is mean effective pressure. How to calculate that mean effective pressure? We know already. Mean effective pressure can be calculated with the help of this equation. What is that? Mean effective pressure is the pressure. It is a ratio of net work to the swept volume. So to swept volume already calculated, swept volume for individual cylinder already calculated. Dear students, you have to keep it in mind. I am doing calculation per cylinder. But he has given 4 cylinders. Now what I have done? Swept volume also divided by 4 and I calculate swept volume for individual cylinder. I mean, I am going to do calculations per single cylinder. Okay, so now fine. Now to calculate work net, so Vs already we know. To calculate mean effective pressure, I should know the value of W net. To calculate this W net, we should know the value of temperatures. Why it is temperatures? We know already. Work net. Work is nothing but generally we know heat supplied minus heat rejected. Because heat supplied is taking place at constant volume in the Otto cycle. That we know already. Heat supplied is going to take at constant volume. Heat is also going to reject at constant volume. So heat supplied, how I can write it now? Qs is equal to what I can do now? M into Cv into, that is T3 minus T2 minus M into Cv into, that is T4 minus T1. So to calculate the work done, because to calculate the mean effective pressure, I should know the value of W net, work done, net work done to the swept volume. Swept volume already know. To calculate this, we have the equation. So therefore W net is equal to, this is the equation. To calculate the net work done, what are required here now? I should know the value of what? T3 and T1. So T4 and T1, sorry, T3 and T2, T4 and T1. That means what all temperatures are required here now. Whereas mass is nothing but what? M is equal to 1. Per kg we are going to calculate, hence we can take M as a 1 kg. Then specific heat at constant volume he has given, that we can use here now. That too for particular things now. So far now, what is my intention here now? I need to calculate all temperatures now. To calculate this temperature, I will go with what? First step. What is the first step now? You can see here, dear students. What is first step now? The first step 1 to 2. Process I will go with what? Process 1 to 2. So process 1 to 2 I will go. Then I know the ratios. I can write the temperature variations with volume. That is the equation, standard equation that you can use here now. T2 by T1 is equal to V1 by V2 to the power of gamma minus 1 or K minus 1. So where V1 by V2 is nothing but what? R actually. So already we know compression ratio is V1 divided by V2. So dear students, V1 represents what here now? Total volume. That one more word we can have, total volume. The total volume, how we can write it now? Vt is equal to Vs plus Vc. So that you know. So V1 divided by V2. That is nothing but what? R actually. So that R value already we calculated now. Now I need to calculate the value of what? T2. Because T1 he has given in the problem itself. V1 by V2 already calculated. K also you have calculated. Then what you can do now? You can calculate the T2. So therefore what will happen? T2 is equal to T1 into R to the power of what? K minus 1. So now what I can do here now? T2 is equal to, what is T1 in Kelvin? 297 K into R value, that is 9.33, that we know already, to the power of what? 1.4 minus 1.404 minus 1. Do simplification, you are going to get T2 value as 712 Kelvin. T2 is done. T1 is given in the problem. T2 you calculated. Next I will move towards T3 value. Like that, I need to calculate P2, T2. All values I will try to calculate here now. So in the same process, I will try to calculate the pressure variations also. P1 he has given, P2 is not at all given. I will try to calculate that P2 also here now, because it required for some other calculations. For that purpose, what I will do, in the same process, I will try to calculate P2, T2, P3, T3, T4, T1, T4, T1, T4 and P4, T1, P1, like that, all pressure and temperature each point. So now P2 by P1 is equal to V1 by V2 to the power of what? K actually. What is V1 by V2? That is R. Now so therefore P2 is equal to P1 into R. So P2 is equal to P1 into R to the power of what? K. So then what we can do now? P2 is equal to 1 kilopascal multiply P1, you know, 1 kilopascal, 9.33. Then you are going to get P2 is equal to 240822 kilopascal, 2408.22 kilopascal. That means what? 24 bar. P2 you have calculated. Next, 1 minute. Fine. Okay, fine. Now calculated the P2. Now I will move towards next. I will try to calculate P3 and T3. So we given, but in the problem T3 has given in the problem itself that maximum cycle temperature has given 1400 degrees Celsius he has given. We have converted that degree Celsius into Kelvin by adding 273, that is 1673 Kelvin. But P3 we don't know. I will try to calculate P3 because it's a constant volume process, hence P3 by T3 is equal to P2 by T2. Now with the help of this relation I can calculate the P3. How to calculate P3? So T3 we know, P2 we know, T2 we know, only unknown is P3. I will substitute here now. I will do simplification and I will try to calculate the value of what. So now, so P3 is equal to P2 by T2 into T3, P2 into T3 by T2. What is P2? That you already calculated here now. It is in terms of kilopascal. Unit you can put, you can maintain consistent units, then later you can convert it into some other as per your requirement, but maintain same units in whole problem. That is very important. Okay, P2, then T3 by T1. Then what happens now here now? Kelvin will get cancelled. Then whatever the things you are going to multiply this with this, what you will get, we are going to 5654.7 kilopascal. That is what P3 value now. That means what? You can see the value also, dear students. That is important. At point 3, according to your this thing graph, it is compression, right? You are going to get here, right? So now this is what? Maximum temperature and maximum pressure. So you can see this P3 is more than what? P2. P2 is 2408, almost double. It is greater. That means maximum pressure we are getting. What we are doing, problem is correct. Next, T4, whether he has given T4, no, T4 is not given. That we can calculate with the help of what? For the isentropic process, 3 to 4. So we have the isentropic expansion, we have the equation. What is that equation? T3 by, so that what is that equation? T3 by T4 to the 4 is equal to V4 by V3 to the 4 of what? K minus 1. Now T4 I don't know, V4 V3 I know, because in the problem itself you can see here now, dear students, that is important. You can see the diagram here now. Otto cycle, V2 is equal to V3, V1 is equal to V4. Once you know the value of V1, that means what? V4 also you know. Once you know the value of V2, V3 also you know. So the same thing I am using here now, the same concept here now. Fine. Now, so V4 is nothing but what? V1. V3 is nothing but what? V2. So now what I will do? I will do simplification. T4, I will try to calculate the T4 here now. I will write V4 by V3 is nothing but what? Expansion ratio, that is our expansion ratio or compression ratio. Somewhere we know the expansion ratio is equal to compression ratio. So RE, both will be remain same if compression ratio is equal to expansion ratio. That means what? Both are same. So both are same. I will take R. So T4 is equal to V4 by E is equal to R. This is expansion ratio to the 4 of what? Gamma minus, K minus 1. Gamma minus 1 or K minus 1. So with help of this equation you can easily calculate the T4, because we know T3, we know R, we know K value, substitute, you will get the T4. So by doing simplification, you are going to get the value of what? T4. How to do the simplification? Do it in a calculator. You are going to get the T4 is equal to 697 0.8 Kelvin. Okay, temperature is decreasing here now. T3 is 1400, sorry, the 1673 Kelvin, but here it is 697. It is decreasing. Okay, fine. Once once you calculated all the temperature and pressure at each point, so you can now easily calculate the work done, because to calculate the mean effective pressure we require work done now. So what is that? Work done is equal to heat supplied minus heat rejected. What is the heat supplied? As I told, that is M into CV. You are going to supply, right? Here supplying, you are supplying heat, right, at this particular point 2 to 3. So how to write the, here you are supplying heat, then here you are rejecting the heat now. So heat supplied minus heat rejection is nothing but what? Total work done. You are going to get it from the engine, that is net work done. So therefore what I can do now, where you are going to supply M into CV T3 minus T4, M into CV T3 minus T4. Similarly heat is getting rejected for the same mass of volume, mass of air, the gas fuel mixture, that is what? M into CV into T3 minus T4 minus T1. So I have written it here now. So what is now? Substitute all the value here now. What is M value? M, you take it as a 1 kg. Per kg you are doing calculations, hence M is equal to in it, that is 1 kg, you take it now. Yeah, fine. Next, what is CV? CV is what, nothing but what? Specific heat for a at constant volume, that is 0.716, that I will substitute. Then T3 I know, I will substitute. Then T2 I will know, I will substitute. These all are what? Units. I am maintaining consistent units. Fine. Minus M is a 1, neglect it because constant mass. Then CV 0.716. Then T4 you already calculated, substitute. T1 also he is given in the problem, substitute. Then do simplification, you are going to get them total work done. You are going to get the net work done is equal to 401.03 Kelvin. Once you know this, then easily you can calculate the mean effective pressure. So already I told mean effective pressure is what? Mean effective pressure is the ratio of net work done divided by swept volume. Swept volume for what? Single cylinder, that you have to remember. So not total work done is 401.3. Then swept volume is what? Is single cylinder, that is what? 0.005, that you already calculated. Do simplification, then you are going to get the mean effective pressure as 802.06 kilopascal. This is what maximum, this is what mean effective pressure. So what is that mean effective pressure and efficiency, that we can see here now. So dear students, whatever the work you are going to get it, right, that is total work done. Okay, then with help of this total work done, what we can do, we can calculate the efficiency now, because this engine is doing this much amount of work. Then to get that amount of work, we are supplying some amount of heat now. So total work done divided by heat supplied, you got the efficiency. That efficiency is equal to how much? 60.6%, that you already calculated. That is the first one. Then when you are going to do some combustion, right, when you are going to give certain amount of heat, right, that is going to create some explosive force over the surface of the piston. You know, you can take the piston over the surface of the piston. That piston is nothing but what? Force means what? It is going to create a force means what? It is going to have a pressure. That pressure, if you are going to take average pressure over the surface of the piston, you can call it a mean effective pressure. Because of that effectiveness of that pressure, the piston will start to move from TDC to PDC. That is nothing but what? Mean effective pressure. That mean effective pressure I can calculate it with the help of this equation. How much mean effective pressure is acting on this piston? That is 802.06 kilopascal, or PM is equal to 8 bar. 8 bar pressure is acting on the surface of the piston, hence the piston is moving from TDC to BDC. Hence if piston moved from TDC to PDC, then what happens? That piston is connected to crankshaft with help of connecting rod. Hence what happens? Crankshaft will start to rotate. Once this crankshaft start to rotate, what I can do? I can move from one place to another place. This is my requirement. This is how to solve the numericals on Otto cycle. Dear students, in detail I have explained this problem for better understanding. So please, the concept and fundamentals knowledge play a very important role. So for that purpose, in detail I try to explain. So please go through my videos. If you have any doubts, please you can contact me, or else you can comment, so I can explain you well. Okay, so this is how to solve the problem on Otto cycle. So Thank you, dear students. One small request from my end. With a lot of efforts and time, and doing such kind of videos. So if you like the videos, please subscribe, comment, and do like and support me. Once again, thank you. We'll continue in next video, next class. Thank you.